So this video is going to be going over the periodic table analysis on page 4. Okay, so we're just going to do some application problems right away. First, we're going to have to put in order these guys in order of decreasing electronegativity. So what you always want to do is figure out what is the most electronegative, okay, element out of everything. And the most electronegative is fluorine, okay? So I'm going to circle fluorine right now, and that's my highest electronegativity. So looking at this, what you can easily do is you can figure out, hey, what's the trend for fluorine as we go across? Well, if this is the highest, think of it as like a mountain peak, so it's like up high. What had to happen to get up to this height? Well, it had to increase as we went across. And what had to happen as we went down? It had to decrease in order for this to be the highest point on the periodic table. All right, for electronegativity, which remember is the tendency to attract electrons, which makes sense. Fluorine would definitely want to gain electrons as opposed to losing them. So we have fluorine. So now we're trying to put in order of decreasing electronegativity. So the next thing that I do is I try to figure out where all of these elements are that we're talking about. So one of them is fluorine, so I'm going to circle that. And then I've got neon right here. And Ta, which is a little tricky, down here. And then we've got Ag, which is right there. All right, so in order of decreasing, that means we have to go from biggest to smallest, which means in this case, closest to furthest. Okay, and literally what you do is you get out your imaginary ruler in your head and you literally measure the distances between these guys. So this distance between this and F, this distance between this and F, this distance, which is hilarious, between this and F, right? And you figure out which one actually is the shortest distance. You're not looking at atomic number, you're looking at literal distances, okay? And so the one that is closest will be the smallest, will be the largest. So it'll be the first one that we'll write. So I'm going to work, so F is first. Well, F is also the largest, so, and I'm going to worry about, okay, cross it off. Now I've got Ne, so I'm going to get rid of this guy. Boop. And now I've got to deal with Ne, Ag, and Ta. Ne is tricky, okay? Ne, even though it's right next to it, so you should normally do it as it's the next smallest, it is actually, or next largest, it is actually the smallest. And the reason why is because these guys, being noble gases, they will never, ever want to gain an electron. So therefore their electronegativity values are 0, and so they are the smallest. So I'm going to deal with my Ne right now while I think of it. Okay? And now I want to go with the next closest, because I'm trying to go from closest to furthest, which would be Ag. And then the final one is Ta. And there you have that one. All right, now let's try to do increasing atomic radius. So the largest atomic radius is Fr. Fr is the largest out of everything. So what that means is you go down, it had to increase. And as you go across, it had to decrease. All right. So now what we're going to do, though, is we're going to actually try to figure out what this guy's is, okay? And once again, I'm going to go with the same pattern. I'm going to circle all the ones that I want, or in this problem. So I've got Ne, Cl, Si, Mg, and K. In order of increasing. So I think it's really important to really take your time and figure out what that means. So increasing means smallest to largest. Okay, and so we're going to go from furthest to closest. Okay, and so what is, and there's no tricks for atomic radius. Okay, so it is the furthest is the first, unlike with electronegativity with that Ne, the furthest is about whatever, is the furthest away, which would mean it's the smallest. All right, so the furthest away would be Ne. So I'm going to write down Ne. Okay, I'm going to get rid of that guy. And then now the next furthest away is Cl. And then Si. And then now I've got Mg versus K. Mg is just slightly a bit further away, so it's going to go Mg. And then it's going to go K. All right, and then there you have it. You don't write FR because it's not in the list. So that's how you do that one. And then now comes a little tricky one, Mg or Mg plus. What you'll also see is magnesium. You'll see this on a few of them. Magnesium or magnesium ion. In order to determine the magnesium versus magnesium ion, you're going to have to figure out what magnesium is. Okay, and magnesium is right here. And you're going to have to figure out what type of an ion would it be, whether it will be positive or negative. And remember, everything basically, these guys all, actually it goes like this, but these guys are all going to be positive, and these guys to this side are going to be negative. These guys are going to have no charge. But that's how you're going to do it. So where is magnesium? Magnesium is a metal, which makes it the positive end. Okay, notice it's right here. It's going to be a positive 2 charge. All right, and so what you're going to want to do is you're going to want to be like, okay, so I know it's a positive 2. So if I ever give you the words magnesium, you know that's Mg. And then I give you the words magnesium ion, that is Mg with a +2. Okay, so now we've got our ideas, okay, because I know it's a +2, so now I can figure out which one is larger. All right, so the next thing that you want to do is you want to think about it, okay? If I lost something, okay, would I be smaller or larger? Because that's what happens to a +2. Remember, you lost something. You lost electrons. Okay, so we had a normal, and then we lost those electrons. So if I lost electrons, will it be a larger or smaller? Well, you're going to be smaller, right? And so which one's larger? Well, that would be Mg. Okay. All right. Hopefully you have a basic understanding of these examples, and good luck with the rest of the homework.